Let's take a look at how electrical resistance is affected by temperature. What I have here is a coil of magnet wire. Now remember, I told you about magnet wire before. Even though it looks like it's bare copper, it's got a coating of varnish on it, which keeps the turns from short-circuiting to each other. So this is actually about 150 feet of copper wire, and I've got it hooked up to a digital multimeter, and I am measuring the amount of resistance. And right now at room temperature we have 3.8 ohms. Now what I'm going to do is I'm going to take this coil of wire and I'm going to dunk it in liquid nitrogen. So here's our container of liquid nitrogen. I'm going to go ahead and drop my coil into the liquid nitrogen and observe what's happening to its resistance. It's going to be going from room temperature, or approximately 20 degrees Celsius, down to about minus 190 degrees Celsius. So that'll be a change of about, 210 degrees Celsius. And you can see it's already dropped down to 0.9 ohms. 0.8 ohms. Okay, so it's dropped down to about 0.8 ohms. I've now placed the coil back on the table, and as you can see, it's slowly warming up. And you'll also notice that frost is starting to appear on the coil of wire because the moisture from the air is actually condensing on the coil. About 5 minutes have passed, and you can see that the resistance is almost back up to its original 3.8 ohms. And if you look at the coil of wire, you'll notice that the frost has started to melt. So that means that it's getting close to being above zero. So what we were able to do by dunking this coil of wire into the liquid nitrogen is we reduced the resistance from 3.8 ohms all the way down to 0.8 ohms. 0.8 ohms is about 20% of its original resistance.